Okay, welcome back to our blood type worksheet. So this is the back page. Here, I'll flip it over. This is the back page of this sheet, blood type genetics problems. The previous worksheet took you through the front page, and at this point you'll have turned it in, and we'll probably have taken any questions. But just in case you want to go through again, here is a quick overview of the back page of this worksheet. Okay, number 4 asks us, a man and a woman both have B blood. The man has the alleles I, capital IB, lowercase I, right here, while the woman's alleles are unknown. Their first child has type O blood. So what is the genotype of the woman? Okay, so without going into all the details, to be type O, that means the genotype has to be 2 lowercase i's. So if the husband is this, he contributes that lowercase I, and the exact same thing would have to be true of the woman. For example, she could have this genotype and be type B, but in this situation she wouldn't be able to have a type O child, so that one doesn't work. So her genotype must be the same as the man, right there. Okay, suppose the man from above with this genotype is heterozygous Rh plus. Okay, so let's write that down right now before we move on. So if he's heterozygous, that means half and half, one type, one of the other, for Rh positive. So because positive is the dominant, we have one uppercase, one lowercase. And the woman is Rh negative because negative is recessive. She is going to be lowercase r, lowercase r. Write the phenotypic ratio or the offspring these two people could produce. Remember, you're working with 2 traits here. So what this is saying basically is that we're going to do a dihybrid cross. Okay, with these genotypes for the ABO categories and these genotypes for the Rh positive negatives. So let's set up our 2 Punnett squares. The first one with our AB, oops, sorry, that's the man's, that's the woman's. Same thing though. Okay, cross that. Alright, we've done a lot of heterozygous crosses, so that should look familiar. Our next square will give us our positive negatives. So this one and this one. Cross those. Okay. So again, before you do any unneeded work, make sure you're counting up the correct ratio. Most of the time we'll just ask you about this phenotypic ratio, which is a little simpler. For example, here you have 1, 2, 3 different genotypes, but only 2 different phenotypes. So 3 of the 4 are going to be type B, 1, 2, 3. So 3 of 4 are type B, and 1 of 4 are going to be type O. Alright, and remember, in these tutorials I will be using what I call the shortcut method, using 2 monohybrid crosses and then doing the math to get the ratios rather than doing the one big Punnett square. But again, you can do whichever suits you best. Okay, over here we've got half, 1, 2 out of 4 that are going to be Rh positive, and 1, 2 out of 4 that are going to be Rh negative. So I'm going to simplify here I'll do this once for you. 2/4 becomes 1/2. So both are going to be 1/2 this one positive, this one negative, and 3/4 times 1/2, 3 times 1 is 3, 4 times 2 is 8, B positive. Same math here, 3/8 are going to be likely to be B negative. Again, these ratios are not absolute. These are basically your percentage chance for that offspring. Okay, same idea over here. So 1 times 1 is 1, 4 times 2 is 8, only 1/8 is likely to be O positive, and then also 1/8 to be O negative. Okay, so as you can see here, more likely to have a child that is B positive or B negative than O positive or O negative. And that makes sense because this is the recessive allele. All right, on to number 5. A man with A negative blood married a woman with B positive blood. Their second child has O negative blood. And we're looking for the genotype of the woman. Okay, so let's do another little inventory of what the possibilities are. So if the child had O negative blood, that means they would have had to, let's just write it out here, their genotype, because these are both recessive, have to be lowercase I, lowercase I, lowercase r, lowercase r. All right, so they had to get essentially the same contributions from mom and dad, which means there has to be one of those for each parent. So if the woman is B positive, she needs a B allele, but she also needs a lowercase I to give to her child. She needs an uppercase R for that positive, but she also needs a lowercase r. So we're just kind of doing reverse detective work here. For the man, he is A, so he needs an allele for A, but he also needs a lowercase I. He's negative, so that means he's definitely got lowercase r's for that as well. Okay, so that wasn't too bad, and it makes it a lot easier with the child with this guaranteed phenotype. Well, sorry, guaranteed genotype based on the phenotype. Okay, so what are the chances of having another child with the same phenotype as their child mentioned above? So we do have to investigate this with a cross. So let's set up a dihybrid cross for both the AB blood type and the positive negative blood type, just like we did above. So I'll start here with the mother and the father over here. Okay, cross those. All right, and we'll do the same for the RH. One is heterozygous from there, one is homozygous recessive. Okay, so now this helps to be very aware of what the question is asking. It is not asking for the full phenotypic ratio like the previous question was, so we can shortcut the shortcut here. So we're looking for only the exact same phenotype as the previous child. So all we have to do is do the math for that exact phenotype. And kind of to reflect back to this previous one, we'll end up with a number like one of these, but we only need to look for, it's this exact phenotype here. So let's find the genotype that will make that phenotype. Okay, so for O, we need this lowercase I. So this represents 1 out of 4 chance for type O. Oops. And then we're looking also for negative. So we have 2 out of 4, or 1/2 negative. All right. And do that math. 1 times 1 is 1. 4 times 2 is 8. For 1/8 chance of O negative. All right. And that's perfect. 1 in 8 chance. So I would say box that in so I know exactly what your answer is, and that's good. All right, so that saves you all the trouble of doing all that extra calculation. Okay, number 6. A woman who has O negative blood marries a man who is homozygous for B positive blood. Show the phenotypic ratio this couple could produce. All right. Here we go again, another dihybrid cross. I know you're probably getting tired of these, but practice makes perfect. All right, O negative, we've seen this a lot today. We know that that genotype is lowercase everywhere. Homozygous, that's very important for this one because otherwise we wouldn't know which possibility, but since it says that, we know that it's all the dominant. Okay, interesting. We've got all recessive alleles being crossed with all dominant alleles. Some of you probably see the writing on the wall here, but let's do the cross anyways. Okay, look at that. Look pretty similar, huh? And you may have guessed it, the same thing's going to happen over here. We're going to end up all heterozygous. So you can do the math, but it's pretty straightforward. 4 out of 4 are that heterozygous genotype. 4 out of 4 are that heterozygous genotype. So that's going to result in 100% being B positive. And that's that. So a little easier maybe than you might have originally thought.